We're continuing electromagnetism. In the last video we talked about the right hand grip rule. In this video we're talking about Fleming's left hand rule. Okay, now this is pretty cool, right? Because it's FBI, like, you know, hands up, FBI. Pew pew. FBI. F is thumb, which is force. B is the direction of the magnetic field, and we know that B is magnetic flux, and we know that it's measured in Tesla. Okay, and then we have I, which is our current, right? So we use this to determine the force that is exerted on a conductor when a magnetic field and an induced magnetic field interact. Okay, so what might happen is a current might be moving through a wire in this direction, and then the direction of the magnetic field might be from north to south in this direction, so the force is felt upwards. Okay, that's just an example. Instead of just me doing this in front of the camera, check out the tutorial video, it will explain it in more detail. There'll be a diagram, and I'm also going to explain how we use the FBIL equation, the FBIL equation. So yeah, check that out, and hopefully it clears up some misconceptions.
Okay, so let's consider this question, or these two questions actually. So the first question is, in which direction will the wire in the motor below experience a force? Well, to answer that question, we need to use our left hand grip rule, where our thumb represents F, the force, B represents the direction of our magnetic field, and I represents the direction of our current. And if we point I in the direction that the current is moving, which is inwards away from us, and then we use our first finger, B, we have to turn our hand upside down to do that. We can see that F is acting downwards. Okay, so with the left hand grip rule, we can see that the force is acting downwards on the wire like this. Okay, so that's how we answer that particular question. And we can do that as long as we have 2 out of the 3 variables, we can figure out the other one. But let's see if we can answer the second part of this question, which is to calculate the magnitude, which is to say the size of this force. If the current is 2 amps, if the flux is 10 Tesla, and the length of the wire is 5 meters. Okay, well, there's actually a really lovely equation called FBIL that links all of these variables together, and it allows us to calculate the force that is experienced by a current carrying wire, just like in this motor over here. Well, how would we answer this question? What we would do is we would write out all of our variables like we have done here, and we would substitute them into our equation. Okay, so F would equal 10 times 2, which would be 20, times 5, which would equal 100 newtons, because force is measured in newtons. And that's how we would use our knowledge of magnetism to answer those questions.
Okay, hopefully that helped you understand Fleming's left hand rule a bit more, and what happens when 2 magnetic fields come into contact. That's going to be important, okay, for when we discuss the motor effect a bit later and transformers, but we'll talk about that a little bit later down the line. Don't worry too much about that for now. So please feel free to check out the rest of our videos. It would really help us. Like, subscribe, share. It really helps the channel grow and us get more content out to you guys, which we love to do. But yeah, stay quantum, and I will see you next time. Bye.